Hello grade 12s. In this video we're going to be taking a look at substitution reactions, or more specifically we are going to be looking at halogenation substitution reactions. Now some of you might remember that halogenation it's also one of the addition reactions that we study. So don't get confused. You're always just going to have to analyze the chemical equation that has been given to you to decide if it's an addition type of halogenation or substitution type of halogenation reaction. The other type of substitution reaction we will study is called hydrolysis. At the end of this set of videos, you will be able to complete exercise 12. So you've already done part 1 and part 2. You'll now be able to complete part 3, which is on pages 128 to 129. And you'll also be able to complete part 4, which is on pages 130 to page 135. So halogenation, as you know, the term halogenation indicates that we are dealing with halogens. We are going to study two types of halogenation. The first type involves an alkane, and the second type of halogenation is going to involve an alcohol. So let's start with the first type of halogenation. They say alkanes react readily with halogens when heated or under the influence of light, specifically sunlight, because it contains UV light. So one of the reaction conditions here is heat or UV light. You're going to see that instead of writing down the word sunlight or UV light, we make use of the symbols H and F, where H is Planck's constant and F is the frequency of the light absorbed. So from grade 10 you might remember that E is equal to HF. So HF just tells us we are providing energy in the form of electromagnetic radiation, specifically UV rays. They say a substitution reaction occurs where the hydrogen atom in the alkane will be displaced one at a time by a halogen atom to form a haloalkane and a hydrogen halide. Okay, so in this reaction, we're going to start off with an alkane. To that alkane, we are going to add a halogen. So remember, your halogens are diatomic molecules, so it will be F2Cl2, Br2, or I2 that we're going to add. A substitution reaction will then occur when we place our test tube or whatever container we're dealing with in sunlight, or we expose it to heat. And we will then have a haloalkane forming and a hydrogen halide. Hydrogen halide just means we have hydrogen bonded to a halogen, where the halogen can be fluorine, chlorine, bromine, or iodine. So the way we know that this is a substitution reaction is an alkane is saturated. It will react to form a haloalkane, which is saturated as well. And here we have triple S or SSS, which says saturated to saturated is substitution. So here's an example of a halogenation substitution reaction involving an alkane. We have methane, and it is reacting with chlorine, Cl2. What then happens is that the hydrogen detaches, one of the chlorine atoms detach, and they are going to be substituted. So substitution is going to take place. We're going to swap them. Instead of now having hydrogen here, we will have chlorine. Instead of having chlorine here, we will have hydrogen. So as a result, we end up with chloromethane and hydrogen chloride. As simple as that. So just remember, when we have a reaction of the sort, we must write the triangle for heat above our arrow, or we need to write HF, which indicates we are placing it in the presence of UV light or sunlight. So again, guys, saturated to saturated means that this is a substitution halogenation reaction. This is not an addition reaction.